I was just going to talk a little bit about angles. First of all, an angle in standard position. So, an angle just could be anything out in the world like this, where we have this part as the angle. An angle is made up of two rays that have the same vertex. Anyway, so you can have an angle like that. But when we're talking in trigonometry, we're often talking about having an angle in what we call standard position. So we're putting the initial side along the x-axis in the positive direction, and then the terminal side would be somewhere else, okay? And we're measuring from the initial side to the terminal side. That would be in a positive direction going counterclockwise around the coordinate system. Okay, so say this measures to be, 70 degrees. We can convert that degree measurement to what we call a radian measurement. And to convert from degrees to radians, you take your degree measurement and you multiply it by pi over 180. And then that's going to change it. So in this case, we would get a radian measurement of 7 pi over 18. Now, a lot of times it will be in terms of pi. If you want to get an approximation for that, you can use 3.14, 15, whatever your pi approximation is, and put that in, multiply it by 7, divide by 18, and you'll get a decimal number, but it won't have a degree attachment to it because it would be in radians, okay? All right, and then if you wanted to go from radians to degrees, you would take your radian measurement, say you have pi over 4 times 180 over pi. And then the pi's cancel and, 180 degrees, because this is going to give you a degree measurement. And that one turns out to be 45 degrees. You can divide that out, okay? So when we want it to be a degree measurement, we have to make sure we put that degree symbol. If it doesn't have that, then it's considered to be a radian measurement, whether it's just a number, decimal number, or if it's in terms of pi. And a lot of times it'll be in terms of pi and it'll be a fraction. So we can convert all those angles that we've been doing before, the special angles like 30 degrees is pi over 6. And we just did the 45 degree one, so 45 degrees is pi over 4. And 60 degrees is pi over 3. And then, you could do all your quadrantal angles and things like that as well. So you want to get used to both the radian measurements on the special angles and the quadrantal angles and the degree measurement. Okay, so let's continue and talk about reference angles. So say we have a coordinate system here. And let's say we have an angle that's 160 degrees. So 160 degrees would measure over that way. And we're talking then about this angle right here, kind of like that, okay? But the reference angle is always going to the x-axis. So you think about what's the closest way for me to get to the x-axis? And that would be right here. Oh, go to blue. Blue. Right there. And that would be the reference angle. And it's going to be 20 degrees in this case. So the reference angle, you're looking for a reference angle to be between 0 and 90 degrees, or 0 and pi over 2. And in this case, you'd get a 20 degree reference angle. So a lot of times we wind up in a different quadrant, quadrant 3 or 2 or something, and we want to get that reference angle for different reasons, okay? Let's do one more reference angle. So let's say we have coordinate system here, and let's say we have an angle that's 320 degrees. So maybe that's probably a little too far. let's say we were going 320 degrees, but then we wanted to know the reference angle. The reference angle would be right here, and that would be 360 minus 320, which would be 40 degrees. So it would have a reference angle of 40 degrees. Okay, so that's, I think, probably what I want to say about reference angles. It comes in really handy with the special angles. So you have an angle of 150 degrees, 150 degrees. So you can think about what that looks like. 150 degrees is over here, but the reference angle is 30 degrees. And then you can use your values that you know for your trigonometric functions for the 30 degree, and then just, you're in the second quadrant, you know which ones are positive and which ones are negative. Okay, so reference angles. And then the last thing I wanted to talk about was coterminal angles. So say you have an angle of 460 degrees. Well, 460 degrees, that's all the way around once. That's 360. And then we'd have to go another 100 degrees. So it's going to be like over here someplace. Yeah, not very straight. But that would be how you would draw 460 degrees. Well, a lot of times we want to know then the coterminal angle. The coterminal angle would just be, you're taking out that trip around the circle, and it's just going from the x-axis to the terminal side. So the coterminal at 460 degrees has a coterminal angle of 100 degrees. And we get that by taking out how many times we went around the circle. You can also do it in a negative direction. So say you have negative 120 degrees, something like this, negative 120 degrees, and maybe we want to know the coterminal angle in the positive direction, so we want to go this way. And so you have to think about, well, what would that be? So you can think about adding 360 to it, or think about, well, the two angles together have to equal 360. So that's going to be 240 degrees. Okay? So those would be, negative 120 is coterminal with 240 degrees. Coterminal angles. They wind up having the same terminal side. But see, it'd be easier for me maybe to think about a 240 degree angle, something positive, than maybe a negative 120 degree angle. They both would have a reference angle of 60 degrees, so that's what I would go with. But okay, so that's just a little bit about, or a little refresher about those types of angles.